Picture this, a city where the buildings and bridges can actually heal their own wounds. A crack shows up, and instead of sending out a repair crew, the structure just fixes itself. Now, this might sound like something straight out of science fiction, but it's a technology that's already here. So let's dive in and see how these living materials are about to completely revolutionize our world.
So why does this matter so much? Well, let's start with this number. $18 billion. That's how much it costs every single year just to repair the concrete we have in the United States. That is a massive, never-ending bill for just patching up the material that holds our world together.
And that really gets to the heart of the problem. You know, concrete is literally the foundation of our modern world, but it has this one fatal flaw. It's brittle. It's super strong if you squeeze it, but it's pretty weak if you pull it apart. And what does that mean? It means it always inevitably cracks over time. Just think about that for a second. We've built our entire civilization on a material that's basically designed to break.
So this leads to a pretty incredible question, doesn't it? What if we could give this material a biological upgrade? What if we could build things that last, not because they're indestructible, but because they can actively repair themselves when they get damaged? To really appreciate just how game-changing the solution is, we first have to understand why these cracks are so much more than just an ugly blemish on the surface.
It's really like a destructive domino effect. It starts with one tiny crack, which lets water seep inside. That water then gets to the steel rebar, causing it to rust and expand, which, of course, creates even bigger cracks. And the patches we use, they're often just a temporary Band-Aid. Now consider that 42% of the bridges in the US are at least 50 years old. Yeah, we are facing a massive infrastructure crisis that simple repairs just can't fix.
But the solution, well, it doesn't come from some new chemical or stronger steel. Nope, it comes from biology. It comes from nature's own microscopic construction crew.
Okay, I know the scientific term is a mouthful, but the idea itself is just beautiful in its simplicity. What scientists do is embed specific types of bacteria right into the concrete mix. They're put in these tiny protective capsules along with their food source. And as long as the concrete stays solid, these little guys just lie dormant, basically sleeping on the job, just waiting. So here's where the magic happens. A crack forms and water gets in. This is the alarm clock. The water dissolves the little capsules, waking up the bacteria and giving them access to their food. As they start to eat, they produce calcium carbonate, which is just limestone, and it hardens, filling the crack and bonding with the concrete around it. It is literally an autonomous, living repair system.
So we know the healing works. That's amazing. But it also creates a huge new challenge. How on earth do you know it's actually happening deep inside a solid block of concrete? Well, the next breakthrough gives us a way to literally see it happen.
I mean, seriously, think about it. For decades, the only way to check on concrete's health was to, look at the surface or drill into it to take out a sample. You're damaging it just to check on it. You could never get a real-time picture of what was going on inside. You were always just looking at the past.
This is just a massive leap forward. We're going from this slow, expensive, and damaging process that gives you one little snapshot in time to a built-in, non-destructive system that lets us watch the healing live as it's happening. So, how is that even possible?
Okay, I absolutely love this part. Scientists took those healing bacteria and they genetically engineered them to produce luciferase. That's the exact same enzyme that makes fireflies glow. So now when the bacteria wake up and start doing their repair work, they also start to produce light. Their actual healing process is directly tied to a signal we can see.
And here is the real breakthrough. We now have a direct link between that light and the rate of healing. It's simple. The brighter the glow, the more active the bacteria are, and the faster the crack is being repaired. By embedding fiber optics into the concrete, we can actually measure that glow. For the first time ever, we can watch concrete heal itself in real time.
So look, this is way more than just a cool science experiment. This incredible combination of biology and engineering is creating a whole new market, and it's absolutely set to change the way we build everything. The projections for this market are just staggering. It's expected to explode from over $114 billion in 2025 to nearly $2 trillion by 2034. And that incredible growth is being driven by this global push for more sustainable infrastructure. This isn't some niche little experiment anymore. It's a technology on the verge of going mainstream.
And this number? This represents the speed of that change.
A compound annual growth rate of 37.5% is it's huge. It signals a revolutionary shift in the entire construction industry, all driven by the demand for smarter, more durable materials.
And what's driving all this growth? Well, take a look. Over half the market is for infrastructure. This technology is being developed to solve the exact problem we started with, our crumbling bridges, tunnels, and roads. This is the key.
So what's the bottom line here? Self-healing concrete means structures that last longer, need way less maintenance, and are just fundamentally more sustainable. We get to reduce the constant need for repairs, which saves money, materials, and a ton of carbon emissions. Honestly, this is the beginning of a whole new era of smart materials that can actually sense and respond to the world around them.
And that leaves us with a final, pretty mind-blowing thought. We're on the verge of giving our inanimate structures a kind of biological immune system. So if our buildings can heal themselves, what other living functions could we build into our world? The possibilities are really just starting to unfold.